a definite shape to it. This one we know will go out like that. And this one has a shape that's kind of like this. And you might have actually seen something in the news that has that shape.
What shape?
Pyramid.
Tornado.
Triangle.
Something in the news.
Nuclear meltdown. Nuclear tower.
Nuclear towers. The nuclear towers, nice job, Avery. Nuclear towers are in that shape. They're in a, they're
Don't they go the other
pergola.
way?
Yeah, but they're.
Pardon me?
Don't they go the other way? Don't they go
Yeah,
up
they
like
should.
that?
They had, well, I don't know, where's my
I was
marker?
upside down. Yeah.
It's like an upside down side tower.
Okay, yeah, I mean, I could do it the other way.
Yeah.
Right, but the point is, all right, it's kind of like this. So you're right, they go upside, if I turned this flashlight down, it would be in the shape that you would be familiar with, okay?
Is that significant to its purpose?
Yes, it is. And it has, pardon me? You're making connections, absolutely. Okay? So, we're gonna move along. Now, the reason why I asked you to do this, the Pythagorean theorem last night, was because, do you have a problem, Zach?
No. We gotta try and pass this. Oh, okay.
Okay, does anybody else need the stapler?
Yes.
Okay, well, I'm going now, okay, so at this point I'm moving. Okay, you guys ready back there? Because I am trying to teach, okay? All right, so in this particular case, if I asked you on a grid to find the distance between that, what could you do?
Count the boxes.
Count the boxes and,
Find the slope.
There is a formula for that.
is the slope gonna tell me the distance?
No.
Slope, I didn't ask you for the slope, what am I asking for?
The line.
The Pythagorean theorem. Okay, so I'm on a grid, I'm telling you that this is 5, and you can see, and unfortunately the graph paper is pretty light, but I could say, oh, I have this pencil doesn't work. I could say, this is, let's look at these points. I could count that this is sort of my triangle. And I'm hoping you can see this on the graph paper. I have 1, 2, 3, and 1, 2, 3, 4 are my distance. So can I now, this is a 3, 4, what do you know, what is the length of that hypotenuse? 5, because it is a 3, 4, 5, which happened to talk about that before. And if not, I could certainly do a squared. 9 plus 16 is 25, so I would know that that would be 5. Okay, everybody good with that? Okay, so, and actually I did do a little picture of you, and you know that when we talk about this being a 3, we're talking about, that's why we're squaring this, because the area of this box is 9, plus the area of this box, which is 16, will equal the area of the hypotenuse, just as a reminder for those of you in geometry. Okay, supposing now I gave you this, and I said to you, all right, maybe it may not be on a graph, how can I figure out those distances? How can I mathematically?
Somewhere you just did
All right, but supposing I could do it on counting on the graph, but I'm giving you an ordered pair. I have 1, 4, and 5, 4. How could I algebraically figure out the distances? Jackie?
Could you subtract one of the x from the other x?
Okay, so let's see if that works. So if I subtract this x, 5 minus 1 is what?
4.
4, and then my 4 minus my 1 is 3. And is that the distance, the is that going to give me the dimensions of these?
Yeah.
Okay, so we're now going to come up with a formula. It's called the distance formula. Many of you learned this last year in geometry. So if I have an ordered pair, and I'm using the Pythagorean theorem as my basis, would you agree with that so far? How did we just do it using these ordered pairs? Jackie, what did you suggest?
You subtract x.
Could I subtract x1 minus x sub 2? So I subtracted my x coordinates, and we, well, 1 minus 5 squared is what? Minus 4 squared, which is what? 16. But because the basis of this is what? The Pythagorean theorem, why am I subtracting?
Find the difference.
To find the difference of the x's, and if this is at 1, and this one is at 4, what's the difference between 1 and 4? 3. So I know that this is going to be 3, so I have to also subtract my y coordinates, and in this case I'm going to have what? 4 minus 1, and 4 minus 1 is 3 squared, 3 squared is 9, and that gives me what? It is the same problem that we just did. I just wanted you to look at this algebraically. Okay, so far so good? Okay. This formula, by the way, all right. So, do I want this as c squared? No, so what do I need to remember to do? I need to take the square root of 25, and that will give me my c. So I need to just remember that last step. That happens to be the formula for the distance right here. And we're going to write that down just to know it in case you ever think about it again. Sometime in your life, I'm going to have x sub 1, x sub 2 squared plus y sub 1 minus y sub 2 squared is equal to c squared.
Wait,
And what?
with what you just did, so wouldn't C be, so C is rad 25 is what you're saying?
What
C
is the squared? Yeah, this is equal to c squared.
So C is
This is equal to c squared. I've been working this side. I'm solving, I want to know what c is.
which is 5, right?
Right, so
What is
c
that?
is equal to the square root of that.
So what is that? Where is C on the graph? that you're-
Whenever I have the Pythagorean theorem, this is, the hypotenuse is always my c. But I don't want c, I don't want, I had what, 16 plus 9 equals c squared? Okay, I don't want c squared. I want, this is my a, this is my b, I want to know what c is. And this formula, the Pythagorean theorem, is based on an area model.
So that's how we find the length of that without the other two sides.
If I just gave you an ordered pair,
Yeah.
okay, previously I gave you the graph, the previous example was I gave you the graph and you could count them, no big deal. If I didn't give that to you and I just gave you the ordered pair, I could subtract them to find the difference, okay? So this is known as the distance formula.
So it's derived from the.
And it is derived from the Pythagorean theorem. So if you're ever in a situation where you need to know the distance formula, it's like, how did we get there? Okay? Now you should be able to figure this out. Correct? I mean, you know, I didn't ask you to figure out how we got the quadratic formula because you really had to jump through a whole lot of hoops to get there, right? You know, you had to complete the square, you had to move things around, take the square root of things, etc. But this is pretty straightforward. All you're doing is taking the difference of the x's. And that's what makes this a little bit complicated, is that you need to remember I'm taking the difference of the x's, taking the difference of the y's, but the Pythagorean theorem is this quantity and this quantity. So that's where the addition comes in the problem. Okay? All right. So, and in this case, if I wanted C, I would then have to remember to take the square root of this quantity, and that would equal C.